All right, in this video, we're going to keep practicing our polar areas, and I'm going to finish BC Homework 10.4. Okay, so the graph of r of theta is shown below, bounds given, find the area. Okay, this one is just the very direct, do we know the formula? Right, so it's going to be 1/2 of the integral from 0 to the square root of pi of r squared d theta. Okay, but that's going to require a calculator for sure. Go over here. I'm going to half of the integral from 0 to the square root of pi of, all right, 3 square root theta sine of theta squared. Okay, need one more parenthesis to close off the 3. Square that 1/2 r squared d theta, but I think 3.534. Okay. Then, which of the following gives the area of the region enclosed by the loop of the graph of the polar curve shown in the figure below? All right. Well, I'm seeing two different bounds of integration. So I would think probably that I should need to be able to plug in these bounds. I'm going to try to do this one without a calculator, show you how you would if you ran into this problem in a no calculator section, right? It's multiple choice. If we saw it, we know that probably the starting and end points are going to be these things here. I got to think, right? Because otherwise, if it started here at 0, I don't see at, well, this is definitely, we're not going to start here because this would not be negative pi over 6 or negative pi over 3, right? So it's 0, so I mean, they're starting here or there. I'd say within reason, we're probably starting here. So let's just try negative pi over 6. All right, cosine of negative 3 pi over 6 would be down here on the unit circle, and that would be a place where x was 0, so that would be 0. Okay, so I feel good about negative pi over 6 to pi over 6. Let's just see what happens when I do, I don't know, positive pi over 3. That would be 4 times the cosine of pi, and that would be negative 4. So I would need to be like, I don't know, down here somewhere, and that's now part of my pedal. So I know that's going to be the negative pi over 6 pi over 6. So I've got this one out and that one out. Okay, now we know it's 1/2 r squared d theta. R squared would be 16 cosine squared. Okay, but then we got to divide by 2. So it's going to be, what's the difference between, oh, okay, this one I didn't remember to square cosine 3 theta. And this one I didn't, I forgot to divide by 2, so that means it has to be e. Area inside the polar curve r equals 4 sine theta, and outside the curve r equals 2. I think it's, yeah, you have to solve for the intercept. I think this is an old problem. I don't think they'd ask you this anymore, but all right, r equals 4 sine theta does look like that, and r equals, so that goes up to 4. R equals 2 looks like that. Okay, and so we want inside 4 sine theta and outside r equals 2. So that would be this region here. Okay, so yep, that's going to be outside minus inside. And it's definitely going to start somewhere, after 0 and stop somewhere before pi. So it can't be that one, right? That's not going to make any sense. We're not taking any sort of area out here where theta is 0, or over here where theta is pi. So I think that pretty much I've tried everything I can. I'm not going to be able to avoid it. I have to find where these intersect each other. So I'm going to set them equal to each other. Okay, divide by 4, get sine theta equal to half. Okay, we're thinking on the unit circle, where y coordinate equal to a half. A half is not very far up, so it would be at pi over 6 and 5 pi over 6. Okay, so I know it's going to be here, and not here, and not here, and now I'm pretty much good, right? So I need to square 4 sine theta. I get 16 sine squared. I'm going to square 2, and I'm going to subtract them. Okay, and then not forget to multiply by half. All right. That wasn't so bad. Let's keep moving it. All right. This is the area of the region bounded by the graph of the polar curve, this and the x-axis for theta between 0 and pi. Okay. This one, I'm going to do it without a calculator because I can tell this is one that you actually can. So it's 1/2 of the integral from 0 to pi. R squared is going to be 1 plus 3 over pi theta. Okay. All right, I'm going to anti-differentiate. Okay, add 1 to the power, divide by the new power, even if dividing by the new power looks a little weird. Right? It's going to be all right. 0 to pi. Okay. And that's going to be 1/2 of pi plus 3 pi squared over 2 pi, so it's really 3 pi over 2. And then both of these are going to be 0 when I plug in theta equals 0. So I've got 1/2 and 1 is 2½ pi. That's 5/2 divided by 2 is 5/4 pi. All right, figure here. Ah, right, Riemann sum approximation. That's good. I'm glad I put this one on here. Okay, so what we're going to do is we're going to write down the integral we're trying to approximate with Riemann sum. Okay, we're going to approximate 1/2 r squared d theta from 0 to 1. Theta equals 0 up to theta equals 1. Well, what that is going to turn into as a Riemann sum is going to be the sum of 1/2 r squareds multiplied by delta thetas. Okay. If I'm using a right Riemann sum, I'm going to take my r value from the right edge of each subinterval. And so, in each subinterval will have width 1/4. So I'm thinking that this is going to go, oh, my computer came unplugged. So I'm going to have, what am I going to have? All right. 1/2 r squared, where we're choosing r from the right, so 1/2 of 16 is 8 times delta theta is 1/4. Plus 1/2 r squared would be 1/2 of 9 times width is 1/4. Plus the third one would be r squared. 1/2 r squared would be 1/2 of 25. Width is 1/4. Plus, okay, choosing from the right edge of this subinterval, 1/2 r squared is 1/2 of 4 is 2 times 1/4. And you see we've got a couple of these that are just pulling out a fourth, but that isn't, I don't see any way that I can pull out fourths and not be left with still these halves. And that's where the 1/8 is coming from. It would have been better if I'd pulled out the 1/2 and delta theta, but it's okay, right? I can still pull out an 1/8, and I'd just be left with here 16, here 9. If I'm dividing by, or if I'm pulling out an 1/8, I'm really multiplying by 8, so 25 and 4. 16, 9, 25, 4. Here it is. Okay, that's choice D. All right, the figure below gives the graphs of the polar curves 2 sine squared theta and 4 sine squared theta between 0 and pi. Which of the following integrals gives the area of the region between the two curves? All right, so that's the region that I kind of shaded there. And so I'm going to say it's 1/2 r squared. The bigger one's going to be 4 sine squared. So if I square that, that would be 16 sine to the 4th power of theta minus 1/2 of the integral from 0 to pi. If I squared this, I'd get 4 sine 4th. Okay, and then if I took these, I'd have half of 16 minus 4, so it'd be half of 12 is going to be 6. Well, that was 15, all right. A couple more for this video, then I'll be doing the extra practice. It never ends. So this one, okay, what is the area of R in terms of K? R equals theta and theta equals K. All right, so what we're going to be doing is, let's weigh in on this and get a thinner pen. So we're really zoomed in. So at 0, we're going to be adding that area, and then we're just going to keep letting theta increase and just add up these areas of these pieces of pizza. All right, until we fill it up, right? So it's going to go from 0 all the way up to theta equals K. And see that? And then, you know, I might write in, it's going to be probably too thick for you even to see at this level of zoom. R equals theta is the curve. Okay, so what's going to happen is we're just going to integrate this function, find the area from 0 up to K. That's all of that effort to just show you that. Well, probably good that I refocus, but cool. Guess I'll leave the image there. R squared is going to be theta squared d theta. Okay, so I'm going to add 1 to the power and divide by the new power. So it'll be 1/6 of theta to the third as theta runs from 0 up to K. And that would be 1/6 of K to the third minus 1/6 of 0 to the third, which is going to be 0. And so that's K to the 6. It's K to the 3 over 6. Graph above shows, still 1, 2 zoomed in. Yeah, that's better. Shows the curve R equals 2 theta plus cosine theta between 0 and pi. Oh, okay, this is a calculator question. This one's just completely direct, right? We're just going to integrate 1/2 R squared d theta from 0 to pi. And we're going to use a calculator. Could not be friendlier. Alright, so 1/2 R squared 2 theta plus cosine theta squared d theta. 17.56. Right, that sounds choice D. Right. And I think that's going to be all I got for you in this video. Okay, if you need more practice, go do the 10.4 extra practice. It's got a lot of the ones where it's the area between two curves. Somewhere it's a region that's bounded by 2 different curves and it hands off from one to the other. And it's a good practice set, so if you're interested, you should go look at that. Thanks for watching.